Welcome to your last algebra lesson of the year for remote learning. You guys have done an awesome job getting through that. It was not easy, so give yourselves a pat on the back. I'm going to try to keep today's video short and sweet with one example that I do out with you and two try it on your own to make sure you have it. And we're going to pull from what we know about systems of linear equations. Now, when we did systems of linear equations, we solved with graphing, with substitution, elimination, and in algebra, we also do the matrix method. And when we solved systems of linear equations, our solution was where the lines crossed. So one solution was when they cross like this and kind of like an X formation. No solution is when they're parallel and they're never going to touch. And infinitely many solutions is when we have the same line on top of each other. They cross everywhere. So today we're going to be looking at when we have one linear equation and one quadratic equation and what that's going to look like on a graph. Think about that. So when I have a graph like this, I have a parabola, it's opening up and a line crossing through. That would be two solutions because again, the solution to a system is a point that satisfies both equations. It's where they cross. When I have one solution, that means the line is just touching the bottom of the parabola. It's touching one time. That's called tangent to the parabola. And last option we have is no real solution. That word real is important in there. And that's when it's not touching at all. So it's going to pass by it, but it does not touch it. So today we're going to solve, this is going to be our example here. We're going to solve one example and we're looking for, the majority of these that we're going to solve in algebra are going to have 2 points. And we're going to solve for x, and those are going to be the x values in our points. So the first thing we're going to do, I'm going to solve this one with substitution. We'll do a try it on your own with elimination. For substitution, remember we're plugging in part of the equation. If we know y equals x plus 4, well, I can substitute it in for that y. So I'm just going to rewrite for now. We're going to say 2x squared, I like to write the quadratic on the left, plus x minus 4 is equal to that linear equation, x plus 4. And now we need to solve. So really at this point, guys, you guys have been solving these using factoring, using completing the square, using quadratic formula. What one am I missing? And algebraically with square roots. You guys know how to solve this already. So I'm going to move this over to the other side, this linear part of the equation. I'm going to move it over to the other side by subtracting the x and subtracting 4. So I'm left with 2x squared. The x's cancel out. So 2x squared minus 8 is equal to 0. Now this is set up great to solve either algebraically with square roots or factoring. And I think I'm actually going to show you both ways. Why not? While I have you. So if I were to factor, I'm going to pull the GCF out. And I could pull a 2 out of that. And I'm left with x squared minus 4 is equal to 0. And now I have difference of squares. That's that pattern you need to recognize. Difference of squares is when I have a perfect square minus a perfect square. And the pattern tells me that that's going to be conjugates. Remember that that's that word for opposites. So I have an x plus 2 and an x minus 2 equal to 0. And now when I solve these, I'm going to set them both equal to 0 separately. That 2 out front right here doesn't matter. We're not worried about it in solving quadratics if it doesn't have a variable. And when I solve both of these down here, I'm left with negative 2 and 2. X equals negative 2 and x equals 2, I should say. So that's important. Those are x values. Now, just to show you another method, if you're going through these and trying to find the easiest way, if you had wanted to solve algebraically, that totally would have worked too. I'll just do it quickly over here. I think this one's actually easier for this problem. If we're solving algebraically, we would add 8, divide by 2. It's just like a normal equation. So I'm left with x squared equals 4. Now to undo something squared, you do the square root. So I'm going to have x is equal to plus or minus the square root of 4, which means it's equal to plus or minus 2. So either way, I get the same answer, a positive 2 and a negative 2. And those are the x values in my system. So for example, if this were the system, I have the x value for this point and the x value for that point. Now I need to go back and find the y's. So I like to leave myself a spot so I don't forget. I found the x value of negative 2. I found the x value of 2. And now I need to go back and find the y's. Now you can plug into either one of these equations. And I don't know about you, but I think this one's way easier than you're dealing with a lot less math there. We're just doing x plus 4. So I'm going to use the linear equation to plug back in. So y equals x plus 4 is my equation. So I'm doing -2 plus 4 to get 2. It's going to go up in here. And I'm doing x plus 4 here to do 2 plus 4, which is 6. That's going to come up in here. So the solutions to my linear quadratic system that we just solved is are -2, 2, and 2, 6. Meaning if I graphed this, the parabola and the line would cross at these 2 points.